Hello friends. So let's talk about ANOVA with a Gage INR study. Let's go back to the Gage INR results of PCB Pro's data. In the last lesson, we saw how variability in the system uh, is split into multiple sources known as variance components. Each component of variation contributes a different value to the total variation in the measurements. For the PCBA viewer data, the majority of variation in the measurements was due to the measurement system itself. It appeared that operator differences were the root cause, but how significant are these results? So can we be confident that our measurement system is imprecise? Gage NR utilizes two-way ANOVA to determine which sources of variation are significantly related to differences in the measurements. To interpret the significance of each variance component, let's look at the two-way ANOVA table for our PCB Pro Gauge INR study. Recall from chapter 6 that the p-value is included in the two-way ANOVA results. So let's focus on this column of p-values to determine which sources of variation are statistically significant. Each p-value corresponds to a component of variation. Remember, a result is statistically significant when the p-value is less than alpha. Let's examine the results of the ANOVA test. We always look at the significance of the path by operator interaction effect first. Given an alpha of 0.05, so is the interaction effect significant? We see the p-value is less than alpha, so the results are statistically significant. Here the p-value is 0, which is less than 0.05, so the path by operator interaction is statistically significant. This result is consistent with the operator by path interaction graph. Notice that operators' three measurements are different from the other operators, and that these differences are not consistent across the circuit boards. Because the operator by path interaction is significant, we do not need to test for significant operator variability. The significant interaction already indicates that operators have an impact on the measurements. So we've tested the significance of different components of variation in the measurement system. But what about variation in the path? The ANOVA table also includes the p-value for the significance of path-to-path variation. A small p-value indicates for the path occurs when we are able to distinguish differences among paths in our measurement system, and a large p-value for the path occurs when the measurement variation is too large relative to the between path variation. So are we able to tell that the circuit boards are different? Because the p-value is less than alpha, so the distance between components on the circuit boards are not the same. Okay, so before we conclude, let's sum up our study of the PCBA measurement tool. We started by looking at graphs and saw that reproducibility error uh, reproducibility error was the largest source of measurement error in the system, and the graphs also suggested that operator differences were the main source of this error. We then dig deeper by looking at the numerical output from the Gage ANOVA results, which confirm our suspicions about operator measurement variation. Furthermore, the ANOVA table provided evidence that these differences are significant. The PCBA viewer measurement tool does not consistently measure paths. They should investigate how they can improve this system so that it produces trustworthy data. So let's review. Gauge INR estimates different sources of variation in measured data. We can use the ANOVA table to determine which sources of variation are significantly related to differences in the measurements. Thank you for your listening. In the next lesson, we'll talk about the gauge linearity and bias study.